Okay, how are we doing, guys? So, we're going to start today with, I think, question 6. So I had one student ask me about question 6, so let's go through that. So, I might just write out the actual question. I don't advise you to do this in exams or anything, because you could write it down wrong, but I'll trust that I'm not going to write it down wrong. This is already a good start. I love doing sums where there's no numbers. Isn't that amazing? Doing sums with no numbers. We're like professional mathematicians here. UA is, oh, U there. What does U stand for? Do you know? You might have learned this last year with Mr. Donoghue. U. So U there would stand for universal. So maybe we should make it into a kind of a fancy U, because it's a very important set. It's the universal set. So in this question, every single element is a member of U. So there's nothing in either of the two sets, A or B, that's not in U. Okay, so we're asked to draw a Venn diagram of that. Okay, so we're going to have two sets. Maybe I might make them a little bit bigger, actually, looking at the number of letters I have. I think I is the 9th letter of the alphabet. If any of you do Sudoku, you might know that I think I is the 9th letter. It's one of those facts, I think. So let's draw a great big Venn diagram. And we're going to call this thing here U. So the name of that set, the name of the square set is U, the universal set. And the name of this set over here is going to be A. The name of this set over here is going to be B. And then let's start putting stuff in. So A and B. So the first zone I want to fill in is always the intersection. So I always want to fill this zone in here first. Okay, so let's go for that. So what is the intersection between A and B? I think the intersection is going to be this guy with this guy and this guy with this guy. So into that intersection part, I'm going to put a little dot, and beside the little dot I put an E, and beside another little dot I put an I. Okay. Now, what's going to go in this zone out here? Well, that's everything that's not in the intersection. So in that zone out there, I'm going to put in this guy, and this guy. So in there, I'm going to put in a little dot with a D, a little dot with an F, and a little dot with a G. And similarly over here, I'm going to put in a little dot with a B and a little dot with a H. Right, so that's kind of neat. So we've taken care of this guy, we've taken care of this guy, but there's some stuff in here in the universal set that we have yet to put in. So for example, A isn't in A or B, so we're going to put in the element A, and I'm going to put a little dot down here and stick him in there. So I have him in. Is B in? B is in. He's over here. What about C? C isn't in, so let's put a little dot with a C beside it. Let's put D. Oh, he's in. E is in. F is in. G is in. H is in. And I is in. So the two elements in the universal set that are not in A or B is A and C. So the element A and the element C are in the universal set, but neither of them are in the actual sets A or the set B. Right, so that's the first part of that question 6 done. That's draw a Venn diagram to illustrate these sets. Now, use the Venn diagram to write down cardinal A without B. So my first job is to go A without B. So A without B is equal to, and it's going to be a set. So it's everything that's in A, and we take away everything that's in B. So from my set A, I take away these parts over here. I take out the entire of B. So I'm going to be left with D comma, F, comma, G. So when I take out B from A, I'm left with this zone in here. And then the cardinal of A without B, well, the cardinal is I count them up. So how many are in that zone? There's this guy, number 1, this guy, number 2, and this guy here is number 3. So the cardinal of A without B is 3. Or the size of A without B is 3. Are we okay with that? Oh, I can't. Sorry, I can't undo now. So we're going to have to leave that yellow in there. Ooh, sorry about that. I thought I would have been able to just... Okay, sorry, I was using an iPad last year and I'm now using a Surface. So it's a little bit different. Okay, so that's how to tackle that question. The next question I'm going to do is U without A. So let's box him off. So we're now going to look at U without A. And again, we don't want U without A. We want the cardinal, or the size of it, the cardinal number of U without A. So that's the universal set. It's the universal set. So it's all of the things that I'm going to put inside a red box. So it's everything in here. But I'm going to take out everything that's in A. So if it's in A, I remove it from the universal set. So it's the universal set without A. So it's basically everything inside the red box with everything in the blue circle removed. So it's going to be equal to, oh, this isn't equal to it. So U without A, first of all, is equal to, well, there's an A down here. There's a C, there's an A, there's a B, and there's a H. So it's going to be A, comma, B, comma, C, comma, H. So that's U without A, and then the size of U without A, well, that's equal to 1, 2, 3, 4. That's equal to 4. Are we okay with that? Yeah? Okay, good. So I'm going to now come along and I'm going to copy my Venn diagram, I think. Am I? Yes, I'm going to try and copy my Venn diagram. Okay. Copy. I'm still getting the hang of this new system. And I'm going to maybe right click. And I'm going to paste. No, okay, I'm not going to do that. So how am I going to do this? I'm going to just draw it out again, actually. Sorry about this delay. I really should know how to copy and paste. So that's A, B, universal set. And in the universal set, we have, in the intersection, first of all, we have E and I. And therefore, in A, we are left with DFG. D, F, and G. And we also have, in B, we have B and H. And then outside we have A, and I think the other one was C. So how's that looking? DFG, DFG, EI, BH, AC, AC. So that's it. Okay, so that was just clearing up a bit of space for us. Now, next thing is we're going to take a look at part IV. And part I, so I'm skipping part 3 because if you can do part IV, you can do part III. If you can do part 4, you can do part 3. So we're going to talk about the size of U without A intersection B. Okay, so it's the size of the universal set without A intersection B. So where in the Venn diagram is A intersection B, first of all? So A intersection B is this zone in here. So, A intersection B is equal to, A intersection B is equal to EI. Now, next thing is U without A intersection B. That's going to equal A, comma B, comma C, comma D, comma F, comma G, comma H. So the size of universal set without A intersection B is equal to, well, it's 1, 2, 3, 4, 5, 6, 7. So it's 7. So the cardinal number of U without A intersection B is 7. So that's question 6 done. So I might jump down and take a look at question 8. But I won't do the entire of question 8. I might just do maybe 2 parts towards the end of question 8. So I might take a look at part 5. And to do this, I might just draw the Venn diagram. Sorry, you really don't need to be looking at me drawing Venn diagrams. You're learning nothing doing that, but I should have a better system than this. I probably could have my Venn diagrams pre-prepared on the notes, but sure. What else would you be doing? You can't really be going to the cinema, or I don't know what else you would be doing. What else do you do? Maybe go to training or something. You can't even go to training. So you have to sit here and look at me drawing Venn diagrams. Right. Do I say right too much? I think I say so, and I think I say right, and I think I say okay far too much. It's only when I look back at these videos that I realize that. My sincerest apologies about that. Okay, so okay, there we go again. Part 5. So we're looking for the cardinal number of U without A intersection B. And I want to know, is it equal to 9? Okay, so the first thing is to find out where is A intersection B. A intersection B, as we said before, is in here. So the universal set without those 2 little elements, is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 big. So this is true. So it is true that the universal set without A intersection B is 9. And that's because there's 11 elements in total. And there's 2 elements in A intersection B. Now, let's take a look at I'm trying to find one that's going to be false for us. I can't find a false one readily. Okay. Yeah, so let's take a look at IV. And IV is sorry, I'll get rid of those red numbers first of all. They might confuse us. destroying my lovely neat Venn diagram. I think that was a 9. I think that's a 9. Oh, that's a problem. That's a major problem, that there's 2 9s in the diagram. So that's a misprint in the book. So I just spotted there because I had to fill this back in. That there should only be 1 9 in the entire diagram, because 9 cannot be in A and it can't not be in A. So that's a fallacy. So if any of you go on to study maths in university or do computers in university, you will realize why that's a really problematic thing. But anyway, we'll persevere. We'll answer the question in the spirit the question was asked. So it's A union B, and we're looking for the size of that. So it's A union B first of all. So it's going to be everything that I'm going to highlight in pink. So it's going to be everything that I highlight in pink, and we're looking for the size of it. So it's all this stuff here. A union B, and there are 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 items in there, and that's not equal to 6. 6. So therefore, so those three little dots written like that, that's shorthand for therefore. So therefore it is false, because 8 does not equal 6. So that's 2 questions in question 8 done. So yeah, so I will see you tomorrow again. I don't really want to move on to anything new, so I'm going to assign you more questions, more of those type of questions, because what comes next is a load of problem solving. So we might just look at problem solving next week. So basically we're mopping up without over the next few days. Okay, so maybe on Friday we might start problem solving, but until then we're going to be looking at the without function, or the without operation in sets. So I'll see you guys tomorrow, and we'll keep looking at without. So I will assign more of those questions for homework or for schoolwork tomorrow. Okay, see you guys.